Welcome to the deep dive. So today we're plunging into something maybe a bit unexpected. You probably know it from the movies.
Right.
That big disaster flick from 2004, The Day After Tomorrow.
Oh, yeah. Hard to forget that one.
Totally. Those, superstorms, the instant freeze, New York getting absolutely swamped by that huge wave. Pure Hollywood spectacle.
Largely, yeah.
But here's the thing. What if I told you that a lot of the stuff in that movie, the stuff dismissed as totally unscientific.
Oh.
Well, it's actually kind of rooted in real science. And maybe the most disturbing part, it's looking more and more like our reality.
That's exactly what we're digging into today. Our mission really is to unpack that film. We're going to look at four key scientific ideas, sort of logical layers that are actually in those crazy disaster scenes.
Okay.
And then we'll get into something even bigger, a really powerful, maybe controversial ultimate logic behind these huge climate shifts, something the movie just sort of hinted at.
Right. So we'll be taking specific bits from the film, connecting them to actual science, real observations happening now. Should be, well, pretty eye-opening. Okay, let's unpack this. So let's start where the movie starts. Those absolutely shocking scenes of glaciers just collapsing.
Yeah, Antarctic ice shelf scene.
Exactly. But the really wild part is how the movie links that to something that sounds, well, backwards. Global freezing caused by the warm ocean circulation getting disrupted.
It does sound backwards, doesn't it? But this warm ocean circulation, you'll also hear it called the AMOC, the Atlantic Meridional Overturning Circulation. It's incredibly important.
Okay, AMOC.
Think of it like a giant conveyor belt in the ocean, right?
Hmm.
It moves warm water from around the equator way up north towards the poles.
Mm-hmm.
And that's why places like Europe, or even Vancouver over in Canada, are way warmer than they should be for how far north they are.
Right, like comparing Vancouver to Harbin in China, even though Vancouver's further north.
Yeah, exactly. Or think about Iceland. It's practically Arctic, but it's green.
Yeah.
That's the AMOC doing its job, delivering all that heat.
Wow. So how do scientists even track something that huge?
Well, there's actually a pretty cool story about that. Back in 1992, this Chinese cargo ship hit a storm in the Pacific.
Okay.
And it lost a container, releasing, get this, 29,000 rubber ducks into the ocean.
Rubber ducks?
Seriously.
Stop.
And over the next, decades, these little yellow ducks started washing up on shores all over the planet.
No way.
Yeah, and tracking where they went helped scientists confirm how this whole AMOC system works, how the surface water goes north, gets cold and salty from evaporation up in the North Atlantic, becomes really dense, sinks deep down to the ocean floor, and then flows back south, eventually coming back up near the equator. It completes this massive loop. Those ducks help map it out.
That's amazing. So, okay, how does the movie's logic connect to this giant duck mapping current?
Right. So here's where it gets, as you said, really interesting. The movie's idea is global warming melts the huge ice sheets, like in Greenland.
All that ice melting.
Exactly. It dumps enormous amounts of fresh water into the North Atlantic. And fresh water isn't as salty or dense as seawater.
Okay, right.
So it dilutes the surface water up there, makes it less dense. And if it's not dense enough,
Can't sink.
precisely, it just sits on the surface. And if it can't sink, it breaks that loop. It basically chokes off the whole warm ocean circulation, stops the conveyor belt.
Wow. And that's the global warming leads to global freezing idea.
That's the core of it. If that AMOC shuts down or even just weakens a lot, all that heat stops flowing north. Europe, North America, they could suddenly get plunged into, Ice Age-like conditions really rapidly.
So, hang on, the warming we're causing could actually flip a switch and trigger massive freezing. That's the movie's big twist, basically. It just turns everything upside down.
It really does. And the worrying thing is, it's not just theory anymore. There's real data, especially since around 2015, suggesting the AMOC has already weakened.
How much?
Studies point to maybe 15% to 20% weaker.
15 to 20%. I mean, what does that actually feel like for people? Are we seeing subtle effects already from that weakening?
Well, it means the heat isn't getting distributed as efficiently. So while we're not talking a full ice age tomorrow, that weakening can mess with weather patterns. It could contribute to more extremes, maybe colder winters in some spots, paradoxically, because that ocean warmth isn't getting as far north.
That's a big deal already. Okay, so let's zoom in like the movie did. That opening scene, the Antarctic ice shelf cracking up, is there a real-world equivalent people are worried about?
Oh, absolutely. There's one glacier in particular. It was discovered back in 1970 by a British scientist. Its name is Thwaites.
Thwaites, and I've heard it called something else.
Yeah, it's often called the Doomsday Glacier.
Right, Doomsday. Why such a dramatic name?
It's down in West Antarctica, right on the edge. And its structure is what makes it so scary.
Mm.
A huge chunk of it is actually grounded below sea level.
A low sea level.
Yeah. And the place where the ice meets the bedrock underneath, it's kind of like a foyer or entryway shave,
Yeah.
very exposed. And that spot is getting hit by warming ocean water.
So it's melting from the bottom up.
Exactly.
Yeah.
Even a small rise in ocean temperature down there acts like like a hot knife cutting through butter at the base. It melts the ice, helps it detach from the bedrock faster and faster.
Okay.
And there's a tipping point. The land underneath actually slopes downward inland. So once it melts past a certain ridge, it's basically downhill from there. The melting just runs away, becomes irreversible.
And the impact of that, if Thwaites goes.
Just the meltwater from Thwaites itself could raise global sea levels by about half a meter.
Half a meter. Okay, that's significant.
But that's not even the worst part. Thwaites is like a cork holding back other glaciers in the West Antarctic ice sheet. If it goes, it could trigger a chain reaction. The whole West Antarctic ice sheet could become unstable and collapse.
The whole thing.
The whole thing.
Yeah.
And if that happens, we're talking about sea levels rising by maybe 4 to 5 meters.
4 to 5 meters. I mean, that's not just flooding. That's cities gone. Miami, gone. Huge parts of Bangladesh underwater. Even the Netherlands, with all their defenses.
5 meters would overwhelm any existing defenses, yeah.
Yeah.
It's exactly that kind of scale you see in the movie, with New York getting submerged. That's the potential locked up in Thwaites in West Antarctica. It really makes you picture places, coastlines. It's genuinely terrifying.
So what's the latest on Thwaites? Is this a far-off possibility, or...?
Well, this is where it gets really alarming. There was research published in Nature magazine, February 2023. Scientists actually drilled down with hot water, sent underwater robots hundreds of meters under the ice shelf.
Wow. What did they find?
Their findings suggest Thwaites might have already passed that critical erosion point, that tipping point. They're saying its rapid collapse might now be unavoidable. The phrase they used was it could shatter like a car windshield.
Shatter like a windshield. Good grief.
And this lines up with warnings back in 2021 that it could collapse within 5 years, which points towards potentially around 2026.
So soon. Like really soon.
The clock seems to be ticking very, very fast on that one.
Okay, so from melting ice and rising seas to sudden brutal cold, the movie also had those scenes of like instant freezing, super cold snaps.
Right, the helicopter's freezing midair.
Yeah, and this connects to another real phenomenon, doesn't it? The polar vortex. I think I remember hearing that was actually discovered during World War II.
That's right, by German scientists. It was properly confirmed around 1948. It's a core part of how our atmosphere works. You know the basics, right? Hot air rises at the equator, cold air sinks at the poles.
Sure.
Well, this sets up big circulation patterns. But around 60 degrees latitude, because the Earth is spinning, you get this really strong band of wind high up like a wind wall.
A wind wall. How fast?
It can be blowing up to like 400 kilometers an hour.
Yeah.
And its main job is to basically fence in all that super frigid Arctic air, keep it locked up over the pole.
So it protects us further south from that extreme cold? So the obvious question then is, what happens if that wind wall, that fence, breaks down? What causes that?
Well, this ties back to what we were just talking about, the AMOC, the ocean circulation.
Okay, how?
If the AMOC weakens, less heat gets transported north by the ocean. That means more heat builds up near the equator. Some of that excess heat gets shunted poleward through the atmosphere instead.
Right.
And that extra atmospheric heat destabilizes the polar vortex. It makes that high-speed wind wall kind of wobble and buckle.
Like a wobble?
Yeah, it becomes unstable. And when it wobbles, big lobes of that trapped super cold polar air can spill out, plunging south into areas that aren't used to it.
And have we seen that happen?
Oh, definitely. We've had some major examples recently. Remember January 2025? North America and Europe got hit at the same time with these monster cold snaps and blizzards.
Yeah, I remember travel was a nightmare. Flights canceled everywhere.
Over 1,000 flights canceled, yeah. Water transport basically stopped. Parts of Utah got like 13 centimeters of snow in an hour. Some places in Europe saw 20, 30 centimeters overnight.
Wow.
And it's not just cold. A paper in Nature just this June 2025 linked crazy extreme rainfall over in Ukraine back in April 2024 directly to a polar vortex breakdown event.
So it causes all sorts of extreme weather, not just cold.
It seems so. Think about the movie showing snow in India. Now, normally the Himalayas would block cold air from the north, right?
Right.
But if the polar vortex collapses high up, that super cold air could potentially spill over the top at high altitude. Now, India itself hasn't actually snowed like that, but look at Guangzhou in southern China.
Okay.
It's also pretty protected by mountains. But it did see snow January 2016, first time in 124 years, then again in February 2022, and again December 2023.
So these cold outbreaks are reaching further south than historically expected.
Seems like it. And those super hailstones the movie showed in Tokyo. That kind of thing happens when these intrusions of extreme cold air smash into warmer, moist air. We saw huge hailstones big enough to smash car windshields in Beijing and other parts of China just this past May and June.
Okay, so the polar vortex breakdown is real, and the effects are real, even if the movie exaggerated the speed and intensity.
Exactly. The underlying physics is there.
Which brings us to another big movie moment. Those absolutely insane super tornadoes ripping through Los Angeles.
Yeah, that was quite a scene.
It makes you think, why do some places get so many violent tornadoes? Like the Great Plains in the U.S., they seem to be tornado magnets. But other places, like China, you don't hear about them nearly as much.
It really comes down to geography and how air masses move. Tornadoes basically form from a violent clash, right? Cold, dry air moving south colliding with warm, moist air moving north.
Okay.
North America, especially the Great Plains, is incredibly flat for huge distances. There's nothing really to stop those big air masses from meeting head-on. It's like a perfect corridor for tornado formation.
The collision corridor.
Pretty much. Now, contrast that with China. You've got major mountain ranges, the Qilin, the Wuling Mountains, even the range down the middle of Taiwan. These act as barriers. They disrupt and largely prevent those really large-scale head-on collisions between huge polar and tropical air masses.
So the mountains break up the flow.
They impede it significantly, yeah. So you just don't get the same conditions for frequent, super violent tornadoes on that scale.
Okay, so the movie's LA tornadoes, that's taking this collision idea to the absolute extreme.
To the ultimate extreme. It's imagining the entire polar vortex just completely collapsing, unleashing all that Arctic air southwards. While at the same time, because the ocean circulation, the AMC, is broken, you have all this hot air building up and surging northwards. It's the collision of all collisions.
Got it. And then after the tornadoes, the movie introduces those terrifying super wind eyes, the things that freeze everything instantly. Is that linked to the bomb cyclone idea?
That's the concept, yes. A bomb cyclone, or explosive cyclogenesis, is named because the atmospheric pressure at the center of the storm drops incredibly rapidly, like a bomb going off.
Okay.
This massive pressure drop sucks air inwards and upwards violently. In the movie scenario, it's sucking down that ultra-cold air from the stratosphere.
Right, the air that freezes helicopters.
Exactly. Now, in reality, even air that's, say, minus 85 Celsius way up high would warm up a lot as it gets compressed coming down to ground level pressure.
Oh.
It might only be like plus 16 Celsius by the time it reaches the ground.
Oh. So not instant freezing.
Not usually, no. However, for the movie's effect, they specifically mention jet fuel freezing, which happens around minus 101 Celsius. For the air reaching the ground to be that cold, the pressure at the center of that bomb cyclone would have to drop to an absurdly low level, way below normal atmospheric pressure, like down to maybe 130 hectopascals.
Which is incredibly low pressure.
Extremely low.
Yeah.
But if it did drop that low, the physics suggest the air reaching the ground could indeed be around minus 106 Celsius,
Yeah.
which, weirdly enough, matches the movie's detail perfectly. It's terrifying physics, highly exaggerated, but there's a calculation behind it.
Well, it's wild that they actually calculated that level of detail. Okay, so we've gone through the glaciers, the ocean currents, the vortex, the storms. Now let's shift gears a bit. The source material we looked at raises a really fundamental and pretty controversial question based on the movie's themes.
Right.
What if the main driver of all this isn't what we usually hear? What if CO2 isn't the main culprit for global warming? And could that understanding actually point towards another ice age? The movie kind of nods towards this, with hints about solar activity, solar black spots.
Yeah, this brings in a very different perspective. It centers around a Japanese scientist, Masatoshi Son. He's described as a national treasure-level Earth scientist in Japan.
Okay, and he has an alternative theory.
A very alternative theory. He's written books with titles like 90% of scientists know CO2 causes global warming is a lie. That was back in 2008. And another one in 2023 called The Great Lie. CO2 is the culprit for global warming. So he's definitely challenging the mainstream view.
Clearly. So what's the mainstream view he's challenging? Just quickly recap that for us.
Sure. The standard greenhouse effect theory, right? Sunlight comes in, some reflects off clouds and atmosphere, some gets absorbed by the surface.
Right.
The surface then radiates heat back out as infrared energy. Greenhouse gases, CO2, methane, water vapor, trap a lot of that outgoing infrared heat, warming the planet. Without them, Earth would be frozen like -18 Celsius on average instead of the +15 we have.
Okay, standard stuff. So what's Sohn's argument against that?
His main point is about scale. He argues that the increase in CO2 since the Industrial Revolution, about a 1/3 increase, is just too small, physically, to trap enough extra heat to cause the warming we've seen. He says it's not like adding a thick blanket. And he points to what he sees as a key piece of evidence. During World War II, industrial activity, and thus CO2 emissions, actually went up significantly in some areas due to war production.
Okay.
But global temperatures during that period actually went down. He argues if CO2 was the main driver, temperature should have gone up, or at least not decreased. So for him, that disconnect refutes CO2 as the primary cause.
Okay, that's a provocative point. So if he says it's not CO2, what is it, according to him?
He champions a different idea, often linked with the Danish physicist Henrik Svensmark. It's sometimes called the Svensmark cloud theory, or focuses on the sun-cloud connection.
Clouds. How do clouds fit in?
The core idea is this. Earth is constantly bombarded by cosmic rays, high-energy particles, mostly from exploding stars, supernovae, far away in the galaxy.
Cosmic rays?
When these cosmic rays hit our atmosphere, they knock electrons off air molecules, creating ions. These ions act like seeds, helping water vapor condense and form clouds. More cosmic rays, potentially more clouds.
Okay. And why are clouds so important in this theory?
Because clouds have a huge impact on Earth's temperature. Think about it. From space, Earth isn't just blue, it's covered in white clouds.
Okay.
Those clouds reflect sunlight back into space. About 30% of all incoming solar energy gets bounced off by clouds. That's a massive cooling effect. Compare that to the CO2 greenhouse effect, which influences maybe 2.5% of the total incoming energy.
Wow. Okay, so 30% reflection from clouds versus maybe 2.5% trapped by CO2's increase.
Something like that, yeah. So Sohn and Svensmark argue that even small changes in global cloud cover driven by cosmic rays could have a much bigger temperature impact than changes in CO2. And interestingly, an experiment at CERN back in 2016 did show that cosmic rays can help create the building blocks for cloud condensation nuclei in a lab setting. It's not definitive proof for the whole climate connection, but it showed the basic mechanism is plausible.
Okay, so cosmic rays influence clouds, but where does the sun come into this? You mentioned a sun-cloud connection.
Right? This is the key part. The sun isn't just putting out light and heat. It has a huge magnetic field, the heliosphere, that surrounds the entire solar system. This magnetic field acts like a shield, deflecting some of those incoming cosmic rays from deep space. And the strength of this shield varies with solar activity, sunspots, solar flares, that sort of thing.
So when the sun is more active,
When solar activity is high, the sun's magnetic field is stronger, and it blocks more cosmic rays from reaching Earth. Fewer cosmic rays mean fewer cloud-seeding ions, potentially leading to fewer low-level clouds, which means less sunlight reflected and therefore warming.
and conversely, when the sun is quiet,
Low solar activity means a weaker magnetic shield, more cosmic rays get through, potentially more clouds form, more sunlight gets reflected, and you get cooling. So Sun argues this cycle, solar activity modulating cosmic rays, which modulates clouds, is the real engine behind global warming and the natural cycles that could lead back to colder periods, even ice ages, not CO2.
that's a completely different picture of climate change. And did Sohn make any predictions based on this theory?
He did. Based on his analysis of long-term solar cycles and other data, he predicted that after 2023, solar activity was due to significantly weaken.
Weaken after 2023.
Yes, and this weakening phase, he predicted, would lead to a period of global cooling by around 2050. He even suggested temperatures could return to levels like those in the 1840s. Think, the Franklin expedition frozen in the Arctic ice, that era of cold.
Wow, okay. Cooling by 2050, driven by a weakening sun starting after 2023. That's a very specific, testable prediction. So
Yeah.
let's do a reality check. What has actually happened with the sun in 2024 and 2025? Did it weaken?
Well, this is where things get really interesting because the reality has been pretty much the opposite of Sohn's prediction.
The opposite. How so?
We've had a whole series of warnings from NASA about intense solar activity. Remember May 2024, between the 7th and 11th?
Vaguely. What happened?
Multiple X-class flares, the most powerful kind, and at least 7 massive eruptions, coronal mass ejections or CMEs, blasted directly towards Earth. NASA called it the strongest solar storm in 50 years.
Okay, that doesn't sound like weakening.
Not at all. Then fast forward to May 16th, 2025. NASA issued another warning, saying the sun is actually at its solar maximum right now, the peak of its roughly 11-year activity cycle. They warned of frequent strong flares and high space weather risks.
And this activity has real effects, right?
Absolutely. It's been implicated in problems with satellites, like SpaceX's Starlink reportedly lost 42 satellites back in 2024, and then over 120 in January 2025 alone, partly due to atmospheric drag increased by solar storms.
Wow.
And even more recently, June 17, 2025, there was another big X1 flare. NASA put out warnings about potential high-frequency radio blackouts, GPS problems, issues for airplanes flying polar routes, even risks to power grids.
So just to be clear, Sohn's theory predicted a weakening sun after 2023, leading to cooling. But what we're actually observing right now in 2024-2025 is the sun at its peak activity causing major solar storms.
That's the situation, yes. The current observations don't seem to align with Sohn's short-term prediction for this specific period.
So what does that mean then? Does it invalidate the whole cosmic ray theory? Or it seems like these are completely opposing views on what's happening right now.
It definitely highlights the complexity and the ongoing debate in climate science. You have different models emphasizing different drivers, greenhouse gases versus solar cosmic ray influences. The fact that we're seeing intense solar activity now, contrary to Sohn's prediction for this period, might suggest that, at least for the current phase, other factors are dominant, or the solar cycle isn't behaving exactly as his model anticipated. It could imply that the day after tomorrow type scenarios, which are often linked to the consequences of warming, like that initial Antarctic glacier collapse, might still be very much in play, driven perhaps more by the factors Sohn downplays.
Right. It suggests maybe the warming trend and its effects are proceeding despite, or maybe even influenced by, this high solar activity in ways not fully captured by either single theory alone.
It's a very active area of research. The sun's role is complex. High activity generally correlates with slight warming, but the mechanisms are debated. Is it direct solar output, or the indirect cloud effect via cosmic rays, or both, or something else? What's clear is the sun isn't currently quiet, as Sohn predicted for this time frame.
Okay, so given all these potential triggers for dramatic climate shifts, melting ice, ocean currents, solar cycles, it makes you wonder, has something like this happened before? A really sudden, drastic climate flip?
There's compelling evidence for at least one such event in our relatively recent geological past. And it connects, fascinatingly, to some mysterious fossilized footprints.
Footprints? Where?
In White Sands National Park, New Mexico, they're incredibly old human footprints preserved in what used to be mudflats.
Okay. What's the story there?
Well, there are local indigenous myths, oral traditions, that speak of the White Sands area once being a lush paradise.
A paradise. It's desert now.
Exactly. The story goes that sky fire fell, and then came endless rain, biting cold, freezing winds. The survivors had to flee south for warmth. And some believe these footprints might actually be a record of that desperate exodus.
Skyfire. Fleeing south from cold. That sounds eerily familiar.
It connects remarkably well with a scientific theory about an event called the Younger Dryas, about 12,900 years ago.
Younger Dryas? What was that?
Okay, so picture this. Earth was naturally warming up. Coming out of the last major ice age, glaciers were retreating, humans were spreading out, creating little oases of settlement around the world. Things were looking up. And then suddenly, bam! The Younger Dryas impact theory proposes that a large asteroid or comet, maybe 2 to 4 kilometers across, broke up as it entered the atmosphere over North America.
An asteroid impact.
A fragmenting one, yes. The theory suggests the largest piece exploded in an airburst low over the Greenland ice sheet. The estimated energy release, equivalent to about 1 billion Hiroshima bombs.
1 billion? My God, what did that do?
The explosion itself would have caused immense devastation. But critically, the intense heat instantly melted a huge portion of the Greenland glaciers.
Melting glaciers. Releasing fresh water.
Exactly. A colossal pulse of fresh water pouring into the North Atlantic. Just like the trigger mechanism we discussed earlier for shutting down the AMOC, the warm ocean circulation.
So the impact triggered the ocean current shutdown.
That's the theory. And the consequences were global. Sea levels rose rapidly from the meltwater, causing floods worldwide. And then, with the heat transport shut off, the northern hemisphere, and potentially much of the globe, plunged back into deep freeze conditions. That sudden return to an ice age state is the Younger Dryas cold period. It lasted for about 1,500 years.
1,500 years? How cold did it get?
Brutally cold and incredibly fast. Scientists have found things like woolly mammoths flash frozen in Siberia with undigested summer grass still in their mouths and stomachs. It suggests the cold hit so fast they didn't even have time to digest their last meal.
Flash frozen mammoths. That paints a picture.
It really does. So you see the parallel. The last time something like a day after tomorrow scenario seems to have occurred, according to this theory, it was kicked off by a catastrophic event hitting Greenland and disrupting the ocean
An
circulation.
asteroid hitting Greenland then. And now, maybe gradual warming melting Greenland and Thwaites, potentially combined with shifts in solar activity, leading to the same circulation disruption.
It's a chilling historical echo, isn't it? Different trigger, potentially similar catastrophic result.
Wow. Okay, we have covered a lot of ground here. We've gone from the warm ocean circulation, the AMOC, and how fresh water can shut it down,
The global warming to global freezing link.
to the Thwaites Doomsday Glacier and the very real threat of massive sea level rise.
Potentially passing its tipping point already.
Then the polar vortex breakdown causing extreme weather further south.
The wobbly wind wall.
The physics behind super tornadoes and those instant freeze bomb cyclones.
The collision of air masses and extreme pressure drops.
And finally, delving into that controversial alternative theory about cosmic rays, clouds, and the sun being the real climate driver, challenging the CO2 consensus.
Right. Sohn's theory and how recent solar activity doesn't quite match his short-term prediction.
So, after all that, what does this tangled web of science, theory, and movie plots actually mean for us, for you listening?
Well, I think the main takeaway is how much of the science behind the day after tomorrow, even the parts that seem most outlandish, have real-world parallels that scientists are actively studying and increasingly worried about. The convergence of evidence, the weakening AOC, the state of Thwaites, the increased frequency of polar vortex disruptions, it makes the movie feel less like pure fiction.
And more like a possible script.
Perhaps, yeah. Or at least a warning narrative built on plausible, interconnected scientific concepts that are looking less theoretical and more observable. The urgency in the scientific community around these issues is palpable.
So here's a final thought to leave you with, something to chew on. Our source material touched on this idea. For the absolute worst case day after tomorrow scenario, that full 5-meter sea level rise wiping out coastal cities, it requires not just Thwaites, but the entire West Antarctic ice sheet to collapse, triggered by Thwaites.
Right, the full domino effect.
Now, maybe preventing that full collapse, stopping the chain reaction after Thwaites goes, is the only escape route left for us. It hinges on the idea that we can still halt global warming quickly enough to stabilize the rest of the ice sheet, even if Thwaites itself is doomed.
A narrow window, perhaps.
But what if that recent research is right? What if Thwaites, the trigger, is already past its point of irreversible collapse? If the first domino is already inevitably falling, does humanity actually still possess the ability to stop the warming trend fast enough to prevent the others from tumbling? Or are we already locked into a trajectory past the point of no return, heading towards our own real-life day after tomorrow?